so kom ons doen nog hierdie laaste bietjie van besproeiing of irrigation. Nou dit kom op hy JOP's wat ek vir julle gestuur het, of in English the ATPs that we sent you, is the irrigation part. I helped create this one. It's nog 'n lekker enetjie to work with. So dis 'n lekker enetjie die, kom ons doen nog 'n eerste. Daar is hy, right. So. Hierdie dingetjie reg bymekaar kry. Right. Besproeiingsmetodes en toerusting, identifikasie, werking en basiese komponente. So basic components for irrigation and equipment that we use. So die eerste een is windpompe, windmills. 'n Windpomp is 'n pomp wat water uit 'n verskeidenheid waterbronne pomp en sluit in boorgate en putte. Die gepompte water word gewoonlik gebruik om skoon drinkwater aan besproeiingsgrond of vee en mense te voorsien. So the windmill is basically used to pump water from a borehole or a river to an area where there is no water. Onthou, as jy 'n plaas het langs die Oranje rivier, maar jy's nie letterlik langs die rivier nie, hoe gaan jy die water van die rivier kry by jou plaas? Deur 'n gebruik te maak van 'n besproeiingsmetode of 'n pyp of enigiets van daai mooi goedjies. Jy gaan mos nou nie soos ons nog geleer het by die vorige periode met die emmertjie maar hardloop en daar hardlooparme dan dek af haar dood op en af om die water te gaan gooi. Dit gaan nie werk nie. Ons probeer 'n groot hoeveelheid water kry van punt A na punt B. So we use irrigation systems and equipment to move a lot of water from point A to point B. Dis eintlik hoe dit werk. Windpompe word ook gebruik om oorstroomde gebiede te verlig van oortollige water en vir die vervaardiging van sout uit seewater. So we also can use windmills to create salt out of seawater and also removing flooded water from an area. So as jy weet jou area vloed baie, klap die windpomp daar, as die vloed kom, laat die windpomp loop, dan pomp die water van daai punt af weg na die ander plek toe. Koppel die pomp aan 'n pyp, die pyp lê weer sê maar 'n rivier toe of dam toe en dan pomp jy al daai oortollige water weg. Onthou mense, te veel water is ook nooit 'n goeie ding nie. Want dit kan gronderosie veroorsaak, met ander woorde die water spoel die topsoil weg. Dit kan oorversadiging van grond wat later lei tot basiese jou goed vrot basis, die wortels vrek, hey? Jy versuip jou plante, you can basically kill your plants with too much water as well, and you can also cause erosion. And the problem, that's a big problem in South Africa, is erosion, because we had a long drought. So our good topsoil that we need for plants, they get washed away. And that's the problem. Right. Die belangrikste tipe windpomp is die piston pump of die centrifuge of monopompe. So the most important pump that you get in a windmill is a piston pump of a centrifuge pump. Hulle sê die horisontale as van die windpomp wat meer algemeen gebruik word en die vertikale as van die windpomp is beskikbaar. Nou mense, daar is meer horisontale parte as vertikale parte. In die algemeen kan windpomp of pompe vir twee groepe verdeel word. Die rotorskag en die horisontale as windpomp loop parallel met die grond, terwyl die vertikale as windpomp loodreg met die grond loop. So there's two types of windmills, one that goes horizontal and one that goes vertically. En die vertikale een is die een wat julle ken, is die enetjie wat ons al gesien het. Yes.
Jy weet dat die dag kan die wind so baie sterk word. Kan jy die pomp stop dat hy nie nog stop kan?
Daar is 'n metode om die pomp te stop. Ja, jy kan die pomp stop. As jy nou weet die wind gaan nou vandag storm, dan kan jy die pomp stop. There's a chain or a break. Ja, kan 'n ketting of 'n breek wees, ja. Dit is moontlik, maar onthou nou ja, nee, hou maar vas. But we won't do that. Die tipes rotors wat in horisontale as windpompe gebruik word is gewoonlik 'n multi-lem of 3-lem rotor. Now usually we use a multi-blade or a 3-blade, but the multi-blade works better. The 3-blade one, it gets a bit heavy and it's not that as effective as a multi-blade. More than 3. A multi-blade is meer as 3. Yeah, only in the electrical windmills that we have. It creates electricity, then we see the 3 ones. You never see ones on farms. Nee, jy sien hom op die plaasie. So 'n multi-lem is basies enigiets meer as 3 lemme. Kom ons gaan gou aan.
So, why is it that it's not so high? There's
So I can get up there without any problem. If it's too high, I can't do maintenance on it. As dit te hoog is,
but wouldn't it be more efficient then?
it will be more efficient, but it stops my maintenance because now I have to get a special person in to go work there.
So is there a height limit where you're not allowed to reach?
There is a height limit, I think, but they don't build it higher than a certain area. Remember, this thing is built out of a certain type of metal. It gets very heavy.
Okay.
So, yeah, and the balance as well.
En het woesel, so as dit te
Ja.
hoog is, kan hy maklik afkom.
Ja, kyk, nog 'n ding wat Alex ook al sê, the rust can also cause it to fall down. It rusts quickly. So oppas maar vir dit. Windpomp yster is 'n baie sterk yster. It takes a lot of weight to windmill metal. There's a guy in Aurora. I'm not gonna say any names. I might get in trouble. Maar daar was 'n oom in Aurora wat so vet was. Hulle moes hom 'n stoel bou uit windpomp yster uit. It was too heavy. They had to build him a chair out of windmill metal. So, yeah, it's a very strong metal that you can use.
Nee, maar ek kyk want jy
Hy oom het 'n enkel cap vir 'n bakkie vol gesit. Hy daar praat hy, man se klonk was saam mee op skool. Die windpompe het 'n stert wat outomaties weg van die wind af draai en sodoende die windpomp se rotor na die wind te draai. So, we have a tail on a windmill that if the wind starts blowing onto the tail, it pushes the tail away, putting the blade into the wind. So die stert vang die wind, gooi hom om, nou is die rotor in die wind. So as die wind verander, it's with direction, to keep the direction of the wind.
On the chimney.
Hey?
Like the thing on your chimney.
Like your hand of the chimney, yeah. That thing at the top of the chimney, yeah. In die algemeen word 'n suiwerpomp gebruik vir die pomp wat water uit 'n boorgat uitpomp. So we usually use a suction pump for a borehole pump. Die suiwerpomp pomp dan water na die opgaartank wat later versprei kan word. So this suction pump will then pump water into a tank or JoJo tank where we keep the water. So hy pomp die water van punt A na punt B in die tank en van die tank af stoot ek dit landerye toe. Nou daar's 'n lekker skets van 'n windpomp. Afrikaanse laaitie, sorry, there's no in English guys. That's your positive side. If I ask this sketch, as ek die sketch vir jou gee, dan moet julle min of iets kan sê. Die Afrikaanse kindertjies, ek gaan nou nie vir jou straf as jy vir my die Engelse woordjies daar skryf nie. Dit is nie verkeerd nie. And the same counts for English. I will not deduct marks if you can give me an Afrikaans word for something. But just don't write your English paper in Afrikaans. En dieselfde geld vir julle. Moenie jou Afrikaanse vrae in Engels beantwoord nie. I will klap jou met die kop. Dis hoe dit werk nie.
Swap names.
Ja, nee, moet maar nie dit doen nie. So daar wys hulle vir jou, daar is die multi-blade router, like you can see more than 3 blades. Daarso is die stert, die tail, daar is die toring of die tower. Daar is die pomp, daar sit die pomp rod basis. Dis die ding wat basies op en af beweeg. That's the thing that creates the suction. Okay? Then we have our discharge pipe, dis waar die water uitkom. Die opgaartank, die tower footing, nou julle sal sien, dit is half onder die grond. The footing of the tower is under the ground. Hy is onder die grond geberg om hier te anker. Karen, want as die wind, soos 'n sekere plekke soos die strand waar die wind mos 360.000 km/h waai party daar, dan gaan hierdie ding nie lank staan nie. If you got places where the wind is so strong, you're gonna have to anchor this. Ja, hy styg op, hy waai weg. Jy gaan obviously na 'n gat hy. En Pietie gaan saam.
Gaan net pas op die wind.
Then we have a drop pipe. Now, a drop pipe is basically there where the pipe rod goes in, the pump rod goes into a drop pipe to protect it from being rusted or damaged. Then we have a screen. Now the screen is there to catch rocks and stuff. Die skerm daaronder is basies om die klippe te stop, dat die klippe nie saamskiet saam met die water in die pomp in nie. And dan het ons die pomp of die cylinder, the pump at the bottom, which is a suction pump. En dan is daar die watervlak en dan het val hy daar aan die water in en dan gat ons. Sorted.
Meneer?
Yes.
Is dit partykeer wat jy die windmill se pype bietjie dieper moet gaan?
Ja, dit kan gebeur as Alex vir hy so moet ons die windmill se pype 'n bietjie dieper maak? Jy kan ja. As die watervlak daal, dan kan jy hom 'n bietjie dieper maak, maar dit raak mos aan nou 'n dierproses. Remember, the more I add on, the more expensive it becomes. Yes.
With a windmill, must it be a stable surface? Can you do it like skew?
Nee,
Must
must
it
be
straight?
straight. Jong,
I'm
dit
just making sure.
nee, maar
If you're on a hill.
hy het 'n punt, want baie van a lot of these energy windmills can be built sideways. Hy het 'n punt beet. But for this, we have to have a stable. Remember, I have to send people up there to go work on it. If it's not stable and he's standing there and falls over, then I'm in trouble.
No, it's still stable, but it's on an angle.
No, it won't work on an angle.
Wat gaan as jy nou vlekkamp staan?
Dan moet jy maar 'n plan maak. Karen het jy vrae gehad. Jy gaan vir hom moet gelyk maak. If you on an angle, you have to make it flat. It's easier to work. It's baie maklik om remember, putting down something on an angle straight down is going to be very hard. Because the pipe has to go straight. There may not be any bends in the pipe. Hy moet reguit afgaan. As hy nie reguit afgaan nie, dan gaan die water nie reg opkom nie. The water has to go through an angle, it doesn't work. Dit is nogal rof. Daar wys hulle vir jou 'n lekker mooi pomp basies. Daarso is die hele stelsel. There's the whole windmill system. That's how it works. Daar is die binnekant van die windpomp. The inside of the windmill. Daar is hy op lekker bymekaar. Nou, die volgende ding wat ons na kyk is 'n watertoring. 'n Water tower. 'n Watertoring is 'n struktuur ontwerp om 'n reservoir van water te hou en ook om te help om die waterdruk op die plaaswaterstelsel in stand te hou. Now, a water tower is basically built as a reservoir. It's usually very high up.
But
Right.
you've got a small, they have very small ones.
Right?
It's like little reservoirs.
You get little reservoirs, yes, but now in a water tower's idea. If you're in a place where there's no water pressure, you have to use gravity. So if the water tower is 10 meters up, gravity will force that water down through the pipe to the other end. So as jy nou op 'n plek kom ons sê julle is op 'n plek soos Put sonder water of Pofadder of Kenhardt of een of ander plek daar, en daar is nie waterdruk op jou plaas nie, moet jy waterdruk maak. En om dit te maak gebruik jy watertoring, want gravitasiekrag forceer die water deur die pyp van die top af tot onder waar jy dit wil hê. So he's basically forcing water through a system. Hy maak 'n makeshift waterdrukstelsel.
Is it
But-
that why you see the water thing?
Mm.
It's in a high place. It's not touching the ground.
Not touching the ground. Hierso, watertorings is al vir eeue gebruik om watervoorrade te hou. Baie boere gebruik watertorings om as 'n rugsteen van die watervoorsiening om te verseker dat alle mense en diere toegang tot vars water het. So we use this to ensure that all people have fresh water and that my animals have fresh water. If I do not have enough pressure, remember, how do we get pressure? It comes from a system with pumps and stuff. But if you don't have that on your farm, this is going to have to be the next best thing. Dis hoe die waterdruk gaan werk. Julle sal sien op baie van die ou plase daar's die showers nie. Dis maar net die bad. Daar's die showers, ja. Shower, was nie genoeg druk vir die shower nie. There's not enough pressure there.
So how do they get all the water up the water tower?
That is done with the 1 or 2 pumps that they do have.
Okay.
But they're not going to have a lot of pumps on the farm.
Okay.
Dis nie nodig altyd nie.
Dis vir krag op kasman.
Krag te spaar en wel
Different seasons.
geld. Die different seasons, different money. Die meeste klein opgaartenke kan tot 'n dag se watervoorraad hou. So many of the small reservoir tanks, like the JoJo tanks, can have at least a day's water for a farm. So baie van hierdie klein opgaartenke kan tot en met 'n dag se water stoor. Toe ek op Koelsberg gewerk het, het ons 'n 10,000 liter, ofwel ek praat onder korreksie, dat ek 'n bietjie meer wees. Het ons 'n reservoir gehad, 'n tank bo wat al die water vir die kosses verskaf het. En in Koelsberg, wat interessant was, ons water was af. Elke oggend van 8 uur af tot vanaand 6 uur toe.
So heel dag met 'n tank aan.
So die water loop net in as die water aan is. Van daar af moet ons deur die tanks werk. Dit was baie moeilik daai tyd toe ek daar gebly het. Maar dit was maar Koelsberg se probleem want die dorp het 'n reservoir gehad bo op 'n kop. En as hy reservoir leeg was, het die pyl boontoe gewys. As hy vol raak het hy gesak. So jy het in die oggende gesien, hy hang bo. Dan moet hulle al die water in die dorp afsny want die waterdruk was te swak. Laat die reservoir kan volloop vir die res van die dorp. That's how they basically used a water tower to run a town. The problem is you are limited with the amount of water that you can use. So you can only shower at certain hours of the day. You can only go to the bathroom at certain hours of the day unless you have a system that runs the bathroom. Tensy jy 'n stelsel het wat die badkamers hardloop. Die skool het byvoorbeeld tanke gehad waar die toilets gehardloop het.
Just set up your own water tower.
They dug boreholes and stuff like that. Some of the people that
Like
they had
you use the water tower there to make your own mini water tower.
You can if you can just
Own home.
if you can just fill your JoJo tank. Let's say when the water comes on, you fill your tank.
Yeah.
And then you keep, yeah, a lot of them did that. Baie van die dorpsmense het so gemaak. Maar sien, dit is nou, as julle nou gedink het, like in Cape Town, you've never heard of this, nooit het gesien nie, julle ken nie dit nie, julle het allemaal watertank, want ons die water gehad het. Maar dink aan, jou water is af. Van 'n sekere tyd in die oggend, dan niks water tot vanaand toe nie. Hey? Gebeur maar.
Nou, hoe laat?
Dag. Kragkop, dis basies 'n tipe van 'n pomp, jammer. Die kragkop is die funksies om water uit die boorgat uit te pomp. So the kragkop, that pump that we use is to get water from the borehole into the reservoir. Okay? Die soort aandrywing wat gebruik word tussen die toestel en die engine is 'n V-band, 'n ry of 'n platband. And there is a picture of a kragkop. So there is the engine and there is the system. Pyl A, that's number A there, wys die draairigting aan van die dryfband en pyl B wys die draairigting. So if A goes this way, B will be anti-clockwise. If A is clockwise, B will be anti-clockwise. So as A clocks gewys is, gaan B anti-clocks gewys wees. What they usually do in the exam is they give you this sketch and they ask you, A is going clockwise or anti-clockwise? Or B is going clockwise or anti-clockwise? Gewoonlik wat hulle vra. Ek het vinnig vir julle die video's wys wat saam met dit gaan. Now every one of these ATP lessons has a hyperlink that you can click on that opens up a YouTube video that you can watch to explain more about our system.
A wind pump is a type of windmill which is used for pumping water. Hello viewers, this instructional video demonstrates the basic working mechanism of a multi-blade wind pump. Wind pumps are mainly comprised of 18 blades. The blades are slightly bent to an exact curvature. To efficiently capture the wind, a metal rib is fitted snugly to the blade and also has a tab that slots into the hole in the sail center, allowing the two sides to interlock. The metallic bands are fit through the ribs to assemble the sails together. The wheel arms that are screwed into the metallic hub hold the sails of the windmill. The sail structure is mounted on the wheel arms. The wheel hub is connected to a shaft that extends to the gearbox. The shaft, which is connected to the wheel hub, has two gears mounted on it in the gearbox.
Daar wys hulle vir jou daai skets wat ons gehad het. Daar wys hulle vir jou hoe loop die ratte en kan julle nog onthou hoe ons ratte gedoen in teg, die Jan Kriel kinders? We did a lot of gears in grade 8 and 9. Julle weet wat hier aangaan.
As the gears rotate along the shaft, the bigger gears that are meshed to them rotate in the opposite direction.
So it must be another type of
The bigger
gears.
gears are connected to a guide wheel by pitman arms.
Not yet.
The guide wheel is mounted
Next
on a
year.
pitman guide that allows it to slide up and down with the rotational motion of the connected gears. The guide wheel is connected to a pump rod which is extended into the ground. The pump rod goes through a cylindrical drop pipe inside the ground. The pump rod is connected to a plunger that acts like a piston and has leather cups to keep the plunger in direct contact with the cylindrical wall, and allows water to pass only through the valve when the plunger is making a downstroke.
Julle hoor hulle sê jy moet leer, it's a leather not a rubber. Hoekom leer? Hoekom nie rubber nie? Why do we use leather not rubber?
Those rubbers gonna stop the friction.
Rubber stops the friction. Rubber kan ook wear and tear in water. It also wears and tears in water. Dit is nogal interessant hoe hulle ding bou, né?
There is a similar check valve at the bottom of the cylinder that is fitted to a strainer below the water level in the ground. On a downstroke, water is held in cylinder by a check valve and the plunger descends to the bottom, while the water passes through the plunger valve.
Soos 'n basiese non-return valve. Die water kan nie terugloop nie. Water doesn't go back down, it only goes up.
The plunger forces a cylinder full of water into drop pipe.
So is daar twee van daai bone?
Een onder, een bo. Ondersteun laat die water op en nie terug nie.
And out to discharge tank, hence pumping the water out.
And would it be possible that the water
The gearbox is mounted on a mast pipe and is also connected to a tailbone on which the vane is bolted.
En maak 'n suction basis. Hy suig die water uit.
The entire mill can revolve on mast pipe, and vane changes the direction of the mill according to the wind direction. Note that wheel hub or shaft is offset from the mast pipe, and also the tailbone is offset on the opposite side of the mast pipe. The gearbox has a vane spring attached to the tailbone. In high wind conditions, the wind force hurls the mill counterclockwise, pivoting the mill on the mast pipe, whereas the tailbone is parallel to the wind direction.
Nou as die klein sprong dan.
The tension on the vane increases as the mill is furled and holds the mill into the wind or higher wind velocities.
Chico gaan hy vinnig agter, né?
The increased tension on the spring causes the wheel to return into the wind when the wind velocity decreases. Wind pumps have been used since the 9th century, used extensively for irrigation purposes, and provides water as free as the wind. Thank you for watching.
Right, so daar het julle daai ene nou. Daar's so 'n lekker idee van hoe die windpomp werk. Julle kan dit is op julle ATP's, op julle JOP's. Julle kan die link weer gaan kyk. Ek moet sê dit verduidelik dit baie beter as wat die boek dit verduidelik. Ek weet dit is nou 'n bietjie in Engels, maar ek meen Charles se Engels is uitstekend. So hy weet presies wat aangaan. Alex gaan vir hom verduidelik wat by die Engels aangaan. Hy gaan hy vir jou verduidelik. Okay, ek het nie geweet nie. Want daar was nog enetjie wat hulle gewys het daar van windpompe wat op die JOP by was. Ek wil hom oopmaak weer. Altyd lekker.
To pump water from the ground, the windmill reaches to the sky. The blades catch the breeze and spin, while gears convert the spinning action into pumping action. This technology has been around for over 2,000 years. The first known water pumping windmills originated in Persia around 7 AD. In 19th century America, this was the wheel of progress, a metal-bladed windmill that turned with greater force than traditional wooden ones, even in low wind conditions. Its superior pumping capacity made it indispensable to pioneers settling inland, away from rivers and streams. Today, this same
Quickly, het julle die klippe daar gesien? Hoekom is daar klippe? Dis vuil water, so iets filtering. Filtreer. Die ou mense het altyd geglo water is skoon as hy oor sewe klippe geloop het. No, it's filtering. Dit filter, hy klippe filter die water. Is baie interessant, nie? Is eenvoudig. Die klippe vang die veiligheid op. Kyk, die klippe is maar nog grof, so al die veiligheid, die stukkies loop sit vas op die klippe. It's not that effective, but it's effective. It's better than drinking, hey? As 'n filtreersisteem nou, it's 'n filtering systeem. Of jy kan steenkool ook gooi. Charcoal can also clean it. Steenkool maak ook skoon. Baie keer as hulle sê as jy nou in die bos is en jy 'n stukkie steenkool en jy het 'n strooitjie en jy wil water drink, sit die steenkool in die strooitjie en dan filtreer jy hom. Way back when there wasn't a net.
Design continues to be part of the rural landscape, especially where there's no electricity to run water pumps. Production begins with a 100-ton punch press. Once activated, it cuts triangular shapes from galvanized steel sheets, each with a slot in the center.
Ek soek so 'n ding in my werkswinkel.
Will be a windmill sail. They'll need 18 for each wind wheel. Once stacked, they transfer the sail shapes to a rolling station. The roller fills the steel to an exact curvature, producing a slightly bowed shape, which will efficiently capture the wind. Next, a worker wraps a metal rib around each sail. He taps the sides until it fits snugly to the sail. The rib has a tab that slots into the hole in the sail's center, allowing the two parts to interlock. Bands fit through the ribs to assemble the sails in groups of 3. Next, a worker slides a metal loop over the guide wheel and drives the ends
depending on what type of metal you use, gears. It's actually very complicated. I don't know. It's a sterk man, it's aluminium.
Next, he inserts the wind wheel hub and shaft into the main.
Dis interessant, hè. Julle ry verby die goed en dink julle vir jouself, ou tegnologie, but look how much effort goes into one of these.
He then grinds the brake lever to shape it to the brake mechanism on the hub. This braking system is critical. It will stop the wind wheel from spinning out of control in high winds. He spins the hub and activates the brake several times to confirm that his machining is dead on and that the brake system works perfectly. If it doesn't, he makes adjustments. Next, using a very toothy circular cutter, he carves grooves into steel blanks to shape the gears. The difference is quite obvious. He installs a set of these gears at the base of the metal loop and secures them with a metal pin. He checks their turning radius. and then mates a larger set of gears to the smaller ones, ensuring that the teeth intermesh. This very substantial gear system will drive the guide wheel, creating the pumping action. Two metal parts called pinion arms link the gears to the guide wheel. A steel pin holds everything together. As the gears turn, the guide wheel rolls up and down the loop to complete a pumping cycle.